In this video I'm going to be looking at the solution to question 5 of the June 2011 Edexcel M1 paper. This is a question about moments. So we're told in the question that we have a plank PQR of length 8 meters and mass 20 kilograms, and it's in equilibrium placed on supports at P and Q, where PQ is 6 meters. A child of mass 40 kilograms stands on the plank 2 meters from P, and we have a block of mass M kilograms placed on the plank at end R. The plank remains horizontal equilibrium, and the force exerted on the plank by the support at P is equal to the force exerted on the plank by the support at Q. We're asked then to model the plank as a uniform rod and the child and the block as particles, to find in part A of the question the magnitude of the force exerted by the plank on the support at P, and also to find the value of M, that's the mass of the block. And then finally just a modelling sort of consideration to state how in the calculations you've used the fact that the child and block are modelled as particles. Well, with all of these questions we need a good diagram of the information. So looking at that, I've started off by drawing the plank P, Q and R at the end there. The force at P, let's call that X. The child has got a mass of 40 kilograms, so we've got a force downward here of 40 G. The mass of the plank is 20 kilograms, so at the center 20 G acting down. There's a force equal to that at P acting at Q, so that is X. And then finally at the end we've got a force mg acting downwards. The distances involved are 2 meters between P and the child. The plank was 8 meters long, so its center would be at a further 2 meters along, and then Q was at a total of 6 meters. So basically these are all dividing the plank into quarters. Right, part A of the question then says find the magnitude of the force exerted on the plank by support at P. In other words, find the value of X. So perhaps the easiest way to do this is to take moments about the end R where M is. So because if we do that, so if we take moments about R, then M will not appear in our equation for moments. So doing that, looking at first of all the clockwise moments about R, we've got X at a distance 8, so that's the force at P. We've also got a value of X at Q, so that's at a distance 2 meters away, so 2X. Those are the clockwise moments. Now looking at the anti-clockwise, we've got 40G, which is at a distance of 6 meters, and a value of 20G at a distance of 4 meters. So that gives us 10x equal to a total of 240G plus 80G, so 320G. So therefore x is equal to 32G, and that would be newtons. And if you wish that's 314 newtons as a number, rather than leaving it as 32G. It doesn't matter, you could get the marks for either way of expressing it. Once we've done the moments calculation in part 1, then part 2 we can look at resolving forces in a vertical direction. Looking at that, then we have a total of 2x acting upwards and downwards, a total of 40g plus 20g plus mg. X, if we leave that as 32g, we've therefore got 64g equal to 80g plus mg. So you can see the advantage of leaving it in that way. G cancels out. Sorry, 40 plus 20 of course is 60g rather than 80g, beg your pardon. And therefore m is equal to 4. Final part of the question simply asks us how we use the fact that the child and the block could be modelled as particles, and all we're looking for here is the fact that they can act at a point. So we're using the idea that they are point masses. Right, the marking then. The first part of A, there was a method mark and 2 answer marks, or accuracy marks, for getting the equation at the start, a method mark and accuracy mark for getting the value of x. Then went on with again a method mark and 2 accuracy marks for the resolving vertically, and a method mark and accuracy mark for getting m equal to 4. So 10 marks for that part of the question in total, and then just a B mark for giving some explanation of how modelling was used and how the modelling as particles was used. And that's the end of this question. Solutions to other questions can be found at www.furthermaths.org.uk.